Okay, so what you're going to have here is you're going to have a geometric sequences. We see that it's going to be due tonight. A geometric sequence is a sequence of numbers in which the ratio remains the same. Remember in 4th and 5th grade you did the tables and you had to find the rule? That's exactly what this is. Common ratio found by dividing each term by its previous term. So you can find the ratio by dividing each term by its previous term. Let's look at the first one. Determine whether the following represents a geometric sequence. Say yes or identify the common ratio. Remember, it's dividing each term by its previous term. So if we go 10 divided by 5, I think the rule here is 5. I always put down my rule. 10 times 5 is 50. 50 times 5 is 250. Yes, it is a geometric sequence because the rate, which is the rule, is 5. Here we see that the geometric sequence keeps going down, but it still can be a sequence if it has a rule. We can go backwards because it's easier with smaller numbers, and we see that 5 times 3 is 15. So if we went backwards, we would go multiplied by 1/3, 1/3, 1/3. It's dividing, so our rate is 1/3, or our rule. Or you can say it's multiplying by 1/3 or it's dividing by 3. So yes, it is, and our rate is 1/3. Then number 6, we see that 6 times 3 is 18. We can divide. 18 divided by 6 is 3. So we know that our rule is 3 every time. So our rate equals 3. We can't say 18 times 3 is 24. It's 6 times 3. So this is just the multiplication rules. It is not a geometric sequence. This is a no. Make sure you know that, because 6 times 3 is 18, but 18 times 3 is not 24, so it doesn't work. Number 7, we know that 7 times a negative 2 is going to be 14. We know a negative 2 times a negative 14 is going to be a positive 28. And you see our positive and negatives are every other one, but our rate stays the same. Our rate is negative 2, or our rule, which gives us, yes, the rate is negative 2. 5, we see it's a decreasing pattern. We see that if we divide 40 goes into 80, 1/2. So it's 1/2, and it's going to be a negative 1/2. So our rate is negative 1/2, and it's 20. Here we see 9 times 4 is 36. 36 times 4 is a negative 144. We see all the answers are negatives, so all we have to do is put our rate as 4. So our rate is 4, and yes, it is. Given that you find the next 3 terms, and you just have to know what the rate is in order to find the next 3 terms. We find that the rate is a negative 3. This is a positive times a negative makes a negative. A negative times a negative equals a positive. So if you multiply negative 3 times 63, you get a negative 189. Then you multiply by 3, you get 567. Then you multiply by negative 3, you get a negative 1,701. And that's how you do those. Right here, this one right here, we see that the pattern is going down. So the rule is 1/4. They're all positive. We divide it by 4, or we can multiply by 1/4. So if we multiply by 1/4, we get 48. Multiply by 1/4, you get 12. Multiply by 1/4, and you get 3. So that is how you find what comes next. Here, the main thing is finding the rate. Here the rule is 2. So we multiply times 2, we get 1. Multiply times 2, you get 1/2. You multiply times 2, and you're going to get 1/4. I'm sorry, not 2, it's 1/2. Multiply by 1/2. Because you divided by 2, but you would have to multiply by 1/2 because the rule is going down, so it's a fraction. You multiply. Here you're going up. The rule is multiplying by 5. It's already a negative, so it's going to make each one of these negative. You multiply times 5 is negative 625 times 5 is negative 3125. Multiply times 5, you get a negative 15,625. And that is how you do those. Let's look at geometric sequence. The nth term of a geometric sequence can be found using the following formula. A1 is going to be the very first term, like this is the first term in the sequence. Then R is your ratio. This 5 right here on number 10 would be my ratio. So A to the n, that's the unknown, the nth term, equals A to the first term times R, which is your ratio, which is whatever we get right here, our pattern, n minus 1. So let's look at, because you know what the first one is, you just don't know, so you're subtracting 1. Let's look at this one right here. Here we know that this one, the R, is equal to 3 because it's going up. We know our first term is 3. So A to the n equals 3 times 3 to the n minus 1. N is our is the number of years, is the time. This is our rate right here. So here, if we want to know to the 7th term, because that's what it's asking for the 7th term, or 7 years, it would be 3 times 3 to the 7 minus 1, which would be 3 to the 6th. So 3 times 3 to the 6th is 2,187. And you can just put that into your calculator. So A to the 7th year equals that. Number 12, if you look at number 12, you see that 4 is your first term, so that is your A1. The rate is 5. 4 times 5 is 20. 20 times 5 is negative. It's not just 5, it's negative. Negative 4 times negative 5 is 20. 20 times negative 5 is negative 100. So our rate is negative 5, and that's that number right there. And then n minus 1. Our n minus 1 is going to be 7, take away 1, which is 6. So negative 5 to the 6th power times negative 4 is going to give you 62,500. And I would do negative 5 to the 6th power first, and then multiply it by your negative 4. Put it into your calculator. Negative 5 caret 6 is how you would do that. Let's look at your next example. Number 13. Let's look at number 13. Number 13 says, we see the pattern is going down, so you're going to have a fraction. We see they're all positive, so it is a positive 1/2. So 400 is your first term. 1/2 is your rule. N minus 1. We're still wanting the 7th. 400 times 1/2 to the 7 minus 1, which is 1/2 to the 6th. I would do this piece here, then multiply by 400, and you should get 6.25. Then if you want 1, 5, 25, the first term is 1. The rate is 5. In this instance, the R goes here. The time is up at the top, 7 minus 1, which is 6. 1 times 5 to the 6th power. So you're going to do 5 to the 6th power times your 1 is going to be 15,625. Number 15, your pattern is going up. They're all negative, so it's going to be a positive 4. Negative 1, which is your first term right here, times the rate, and you're going to have to figure that rate right there. 4 to the n minus 1. So a to the 7th, so if you're looking for the 7th term, negative 1 times 4 to the 7 minus 1, which is 4 to the 6th, is 4 negative, make sure you look at that negative 1, negative 4,096. But the only thing you're really having to figure is this pattern. And all you have to do is go 4 divided by 1, it gives you 4. Here we can go 243 divided by 729 gives you a negative 1/3. Negative 1/3. So 729 times a negative 1/3 to the 7 minus 1 gives you 1. So that's a funny answer, isn't it? So your answer would be 1 here. The next one, you see that 6 times 2 is 12, 12 times 2 is 24, so we are multiplying by 2. We see a positive, negative, positive, so it's going to be a negative 2 because the 6 is positive, and we need to make that a negative 12. A to the n equal 6, first term, times my negative 2, my rate, n minus 1. We're still finding the 7th term, so 7 minus 1 is 6, and so when you do 2 to the 6th power, negative 2 to the 6th power, it's going to make it positive because that's even, times 6 is 384. The next one, A, 12 divided by 8 equals 3/2 when you reduce it. 8 times, here's your 8, 3/2 is your r, n minus 1. A to the 7th, so A times 3/2 to the 7 minus 1, so is 6 like all the rest of them. And when you multiply that out, it's 91.125. And then, this is the application. The table to the left shows the car value for 3 years after it's purchased. So if you divide 10,000, you see that the pattern is going down by 8,000. 8,000. We can get rid of 3 zeros, so it's really 8 divided into 10. And when you go 8 over 10, when we reduce that, it is 4/5. And you see that you can do that. So it's 8 at the end, 10,000 is my first term, 4/5 n minus 1. If we wanted to depreciate it over 10 years, it would be a to the 10th, that's the 10th year, equal 10,000 times 4/5, 10 minus 1, which would be 9. So that's, this changes to a 9. So 10,000, so 4/5 to the 9th power times 10,000 is $1,342. So on the 10th year, if you were to continue this to 10th, this would be $1,342.18. So in summary, the value of the car is going to decrease in value. It's worth less. After 10 years of having a car and putting on a lot of miles, it's worth $1,342 if you only gave $10,000 to begin with on that car, which probably in today's time, you're going to give a lot more for a vehicle. That concludes this lesson on geometric sequences. If you're still having trouble with these sequences and finding the ratio, email me. We can have a Zoom conference and go back over these. Good luck on your homework, and make sure you turn it in. And you're going to turn in this paper on the homework page on tonight, and you're going to turn in the quiz by Sunday night that comes after this, quiz 3. Thank you.